All right, here's one of my favorite types of problems to give when we first start working through the Pythagorean theorem. I'm going to ask students to plot two dots, and then they got to find the distance between those two dots on a coordinate grid. So first thing I would do is I'd plot -2 and -4. We're trying to find the distance between these two dots on the coordinate grid. So -2, -4, that's going to be 2 to the left, 4 down. It's going to be right about there. -5, -3 would be 5 to the left, 3 down, which appears to be right about there. And we need to figure out how long that is. Okay, now some students realize right away that they're able to create a triangle, while others take a little bit of time, but eventually get to the realization that we need to figure out this distance by turning this into a right triangle and using the Pythagorean theorem. Because I know down here I'm at -4, and right here I'm at -3. So my distance from here to here, from -3 to -4, I can put a 1 as that leg of my triangle. Remember, if we get a leg and a leg, we can find the missing hypotenuse, which is opposite of the right angle. So how would I find out what this leg is? Well, I'm at -5, and this one came from -2. I was at -2, -4. So -2 to -5, -2 to -5. That distance here is 1, 2, 3. So we're dealing with a triangle that is a 1/3 with a right angle there. We use our legs, and a squared plus b squared equals c squared to figure out what our hypotenuse is. So our first leg is 3, 3 squared plus our other leg is 1, 1 squared equals c squared. 3 squared is 9, 1 squared is 1, c squared is still c squared. 9 plus 1 becomes 10 equals c squared. So we're going to square root c squared, square root 10. C, or the missing side length, this distance between this dot and this dot, which were the original two dots, is the square root or radical 10. So that would be somewhere around 3.2, 3.1, 3.2, 3.3, somewhere around in there. Okay, study hard and good luck on your upcoming test.